Okay, so we're going to look and see how to use the distance formula to decide if this triangle is equilateral, uh, isosceles, or scalene. And now you can look at it and say, well, clearly line CB, line segment CB, is not the same as line segment AB or AC. So it's probably not an equilateral. But to determine if it's scalene or isosceles, we have to compare the lengths of the two sides. And then your full spiciest level question is going to be asking you to estimate the angles, because we know that how large an angle in a triangle is determines how long the side opposite is. So, for example, angle A here is going to determine the length of this, because if we were to make this a little bit larger, then BC would be a little bit larger as well. So let me clear this. I can actually, this triangle allows me to drag it. So you can see that if I made the angle here, angle A, larger, that side BC would also be larger. So let's see, this is 12.7. So the question now is this an isosceles triangle or a scalene triangle? We can tell it's not equilateral. Well, to do that, we have to find the distance. Now, a lot of videos will show you the distance formula. They'll say D equals square root of, it'll look like this long, complicated formula that looks like this. And the formula is just another way of doing the Pythagorean theorem. So I'd rather have you, instead of memorize a formula, I'd rather have you think about this as a triangle that you can use the Pythagorean theorem, because that's applicable in so many different ways. So we can say, look, anytime I have a diagonal line, I can find the distance by making a right triangle. So we can see that this is a side of 3, and this is a side of, I could count it, but I could also see, well, look, I went from 2 to 12. So that's a side of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough. So I've got 2 legs of the triangle. I need to figure out what the length of the hypotenuse is here. So 10 squared plus 3 squared equals, and I'll just start giving these. I'll say this is x. This is x squared. So I've got 100, because that's 10 times 10, and 9 equals x squared. Okay. And so x equals the square root of 109. And we see this triangle, and we'll call this y, is, well, it's from 10 to 1. So this is 9, and this is 1, 2, 3, 4, 5, 6, because we can see that's the distance between 2 and 8, our x coordinates. So this triangle, we'd say 9 squared plus 6 squared equals y squared. So I've got 81, that's 9 times 9, and 36, that's 6 times 6 equals y squared. And 81 and 36 is going to give me 117. So y would be the square root of 117. Aha! So we can see that, in fact, they are not the same length. So this must be a scalene triangle. Now, how do I apply these distances to the angles? Well, in a more advanced math class, you're going to learn trigonometry, which is going to allow you to calculate them exactly. But for our purposes, we just want to estimate. And so we know that if this is the square root of 109, and I'm going to pull up my calculator here. Calculator. 109, and we'll take the square root of that. That's about 10.4. About 10.4. And 117, and we take the square root of that, and that's about 10.8. And for us to really get a good sense of how far or what each of the angles are, we really need to know the relative size of the lengths of triangles. So we're going to say this is 10.4, right? About 10.4. And this is about 10.8. And to really do this problem justice, I need to think about how long this side is. So we're going to call this Z. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so Z squared is going to be equal to 6 squared plus 4 squared. So 36 plus 16. Okay, and 36, oops, let's clear that. 36 plus 16 equals 52. Okay, so we'd say that Z is equal to the square root of 52, which is about 7.2. 7.2. Okay. So reasonable estimate of angles is, again, I'm not looking at an exact one. I'm just seeing if you can make sense of how the angles and sides work. So we see that the largest side, let me try that. There we go. Oh no, all my drawing got messed up. Let's see if I can bring this back to the correct place. There we go. Whew. All right. All right. Pen. Okay. We remember that the sides and the angles opposite them are related. So our largest side is AC, and so our largest angle is going to be angle B. So this is going to be largest angle. And the smallest angle is going to be opposite the smallest side. So angle A is going to be the smallest one. And we know that angle C is almost the same side as B, but B is slightly larger. So we might say, well, B is, if B is 70 degrees, then maybe C is 65 degrees. Okay. And since all angles in a triangle always add up to 180, we'd say 180 minus 70 minus 65 gives us 45. Now, I look at these and I look at angle A and I say that looks maybe a little smaller than 45. So maybe these are a little bit bigger. But it's a reasonable estimate because we have the largest angle, the smallest angle, them all adding up to 180 degrees, and 70 and 65 really are close to each other. So this would be a reasonable estimate. Now, if you want to really check, this tool actually tells you what they are. And so this tells us that, in fact, they are 73, 67, and 40. So that's what they are actually calculated to be, but the estimates that I gave you were reasonable estimates and definitely good on a test. I encourage you to go back and pause and replay if you want any